Let's draw ethane. Eth is two carbons. So you connect the two carbons and fill four bonds with hydrogens. So each carbon gets three hydrogens, right? Because hydrogen can only bond to have one bond. Okay, now we can draw the condensed structural formula. One corner is a CH3, the other corner is a CH3. You can also put a line between. Okay, so you can clearly see CH3 is connected to a CH3. Okay, now the line diagram is just a line, but you have to imagine each corner of a line is a CH3. Okay, now using the Lewis structure or the condensed, you can write the chemical formula, count the carbons using any of these two carbons, and then hydrogens 6. Just count the hydrogens also, right? Then let's jump to ethene. That's a double bond, so you need to have eth is 2 carbon and a double bond. Satisfy the 4 bonds for each carbon, so I need to put 2 hydrogens for each end, right? That's that. Now what's the condensed formula? H2C connected with the double bond CH2. That's the condensed, right? Then the line diagram is just a double bond, just a 2 lines, right? Each corner, that means CH2. That's how you want to think about it. Use the 2 first, the Lewis or the condensed, to write their chemical formula, molecular formula. That's C2H4. Count the carbons and hydrogens, right? Now the last one. Ethine is a triple bond. So 2 carbons, eth is 2 carbon, triple bond. Each carbon needs only 1 hydrogen, right? So therefore I can write HC triple bond CH. That's the condensed, and the line diagram is just a triple bond, 3 lines. That's that. Okay, so practice a couple of times for pentene, hexene, and so on. So let's give it a try on this one. So what I have is 2,3-dimethyl pentane. So I'm going to draw 5 carbons, pent is 5, connected with the line. And I'm going to number 1, 2, 3, 4, 5 as I write it, right? And then we're going to satisfy 4 bonds. There's no double or triple bonds, but there are 2 has a CH3 group, 3 has a substituent CH3 group, methyl groups, right? So you need to show them. And then each carbon needs 4 bonds. First carbon is 3, 2 carbon is 1 hydrogen, and so on at the hydrogens. Okay, and let's put the 5 carbon needs 3 hydrogens, and 4th carbon needs 2 hydrogens, right? So complete that one. Now each carbon has 4 bonds, octet satisfied for each carbon, and now 2 and 3 methyl group substituents are done. This is how we write the condensed. Corner is CH3, then CH, and there's a CH3. This methyl is attached, and then next CH, this methyl, third one is attached within brackets, right? Substituents are within brackets, then CH2, and ends with the CH3. So that's the condensed formula. So you can slow down or pause and draw it, write it, right? And then this is how the line. For pentane, it's like an M, right? And each corner is a methyl group. Pay attention to that. And then number again 1, 2, 3, 4, 5, so you're not confused or missing carbons, right? Then second methyl is looking up, third methyl is looking down. That's how we actually draw them properly. Okay, we don't draw it like in the Lewis structure, both the down or up. It should be like that. Let's jump to the next one. This is how you do it. So you number main chain, and then 2 methyl, second position has a substituent methyl, and then you write it 2 methyl, and main chain is propane, right? Because there's no double bond or triple bond, right? 2 methyl propane. So go back and forth, try 2 methyl pentane, right? Okay, all right. UPAC name for this structure. This is tricky. So you see the priority is for the double bond. So you're going to include the double bond, start 1, 2, 3, 4, 5, and notice the main chain included the double bond, giving the lowest number to it. And this is a 2 methyl substituent. This is a 4 methyl substituent, correct? Now we're going to put the substituents first. 2,4 dimethyl. You need to say that how many methyls? Dimethyl. right? And their positions 2, 4. Then the main chain is pentene. It actually has to be pent1ene. Let me put it here, 1-pentene or pent1ene. Either one is correct, right? You need to say where the double bond. Now this is a challenger. If you're not in a major class, you don't have to do it. This is how I would do it. So I would number 1, 2, 3, 4, 5, 6. The carbon chain, identify the triple bond has 5 and 6 2 carbons on it, right? And then also notice double bond has more priority in the naming than the triple bond. So that's why I number that way. Otherwise you're going to flip that numbering, right? So that means this should be saying as 1-hexene and 5-ene, because the triple bond starts at 5. That's it.